As part of our continued commitment to improving the quality and performance of carrier HVAC systems, I'm going to show you how to measure and calculate system airflow, or CFM. In a previous video, we demonstrated how to take the airflow measurements. In this video, we will show you how to use those measurements to calculate the airflow in CFM, or cubic feet per minute. Calculating the CFM is a three-step process once you have completed your airflow measurements. Calculate the velocity for each individual pitot tube reading, calculate the average velocity for all the readings, then use that average to calculate the airflow, or CFM. To calculate individual velocities, take the square root of your pitot tube reading and multiply it by the airflow constant. The airflow constant is 4005 and can be found in the air properties and measurement materials. In this example, the square root of a 0.04 pitot tube reading equals 0.2. Multiply 0.2 times the airflow constant of 4005, and the velocity is 801 feet per minute. You will see that you have a slightly different velocity reading for each point. This is normal and is why you take readings at multiple points. After calculating each individual velocity, add them together. In this case, the 6 velocities add up to 5,610 feet per minute. Divide that sum by the number of measurements taken to achieve the final average calculated velocity. In this example, we divide by 6 for an average of 935 feet per minute. To calculate CFM, you will need to know the area of the duct in square feet. Measure the width and depth of the duct in inches, then multiply the two dimensions to get the area in square inches. In this example, the duct is 10 inches wide times 20 inches deep for a total of 200 square inches. To convert to square feet, you must divide your answer by 144. In this example, the area of our duct is 1.389 square feet. Now you can calculate CFM. Take the average calculated velocity and multiply it by the area of the duct in square feet. Using our example of 935 feet per minute and our duct area of 1.389 square feet, multiply these together and the final calculated airflow is 1,299 cubic feet per minute. We are almost finished with the CFM calculation. Air has different properties at different elevations and temperatures. These differences can be accounted for using the density ratio factor, which is based on the altitude the equipment is installed in and the temperature of the air. This is where you will use the temperature readings we discussed in part 1 of this video, taking the measurements. If our air temperature was 150 degrees and we were at 2,000 feet, our density ratio factor would be 0.808. To determine the actual CFM being delivered, divide the measured average calculated CFM by the density ratio factor. In this example, our calculated CFM of 1,299 divided by 0.808 equals 1,607 cubic feet per minute. Understanding how to accurately measure and calculate system airflow is important. Airflow that is too high or too low can affect component reliability and system operation. Proper airflow is required for comfort, efficiency, and reliability. Thanks for watching Tech Tips.